As the population is growing and we're pushing out into more and more remote corners of the world, we are seeing epidemics on the rise. I'm particularly concerned about animal-human shared viruses. Those are the ones that we've seen most recently and throughout history as becoming really devastating outbreaks, like the horrible Ebola epidemic in West Africa. We are here looking for the world's most deadly viruses because we need to get ahead of this curve and understand a lot more and be ready.
Ebola killed nearly 12,000 people in West Africa, and that needs to never happen again.
Ebola is a virus that is hiding out most of the time, and we don't know where it is. It's living in some animal, and every now and then it will burst out, spill over into our species, and cause terrifying outbreaks, and then it disappears again.
We need to be out in disease hotspots in the wild, testing animals for what viruses they're carrying so that we can find these viruses before they find us.
That's the hammerhead.
That's the biggest food bat in this region.
Yes.
There's a lot of evidence that bats are an animal host for Ebola. But which bat species? And actually, are they the primary host, or is it some species we just never looked in before?
We're checking the bats to see what viruses they might have that could be transmissible to people.
So we have oral and nasal swabs on everybody?
Yes.
The outbreak in West Africa showed us that an outbreak anywhere is a threat everywhere, so you have to be ready at all times.
Viruses have been around for millions, perhaps billions of years.
Viruses have shaped history and how people have evolved.
They are ubiquitous, and they come in all shapes and sizes.
If you took a teaspoon of seawater, you might find millions of viruses in it, in one teaspoon.
A virus without another cell is nothing. It's meaningless. It can't do anything.
A virus is a small package of proteins with a little bit of genetic code right at the center.
And they like to get into cells and trick them.
They're Trojan horses that take over the cellular machinery to make more copies of themselves.
And that's when you can get sick.
Viruses have the capability of evolving, mutating.
Some people think of viruses as little enemies waiting to hurt us. I don't think of them like that.
Viruses are not all bad. Being bad is just one way of being a virus.
They are an essential part of life.
So the struggle goes on, and the viruses change to accommodate, and our job is to try to evolve faster than the virus.
Ebola is classified by the U.S. government as a Tier 1 pathogen. That means it's among the most deadly, concerning viruses to man.
The mortality rate is extremely high. It can be as high as 90%.
We were caught off guard by the experience in West Africa. I think one of the most important things that we learned is that we need to be prepared. This is a biosafety level 4 lab, so a spacesuit lab. A biosafety level 4 lab is the highest level of security that we have in the United States and globally. We're trying to understand how Ebola virus affects the immune system. That'll give us insight into developing better vaccines.
Ebola is spread from person to person when you come into contact with infected bodily fluids.
The viral load that we see in our patients is hundreds to thousands of times greater than any of the other infectious diseases which are spread by contact with blood and body fluids.
With some other viruses, it takes hundreds or thousands or millions of copies of a virus to make you sick. And Ebola takes one.
Ebola, c'est le nom d'une rivière près de la mission catholique de Yambuku, là où le virus a été trouvé pour la première fois. Donc, c'est une maladie, nous appelions à l'époque une maladie mystérieuse. En 1976, le ministre de la Santé, il m'appelle, me dit, professeur Mouyembe, il y a une épidémie à la mission catholique de Yambuku. Donc, sur 33 malades qu'on avait trouvés, il y a déjà 22 décès. Et le soir, j'arrive à Yambuku. L'hôpital était de nouveau rempli de malades, mais j'ai pris l'échantillon de sang chez des cas vraiment aigus. Mais quand je pique, puis j'enlève mon aiguille, le sang continue à couler. Ça m'avait étonné. J'ai fait la médecine, mais je n'avais pas vu ça. Et puis après, on m'apprend que pendant la nuit, il y a 3 infirmiers qui sont morts.
I was 27. I was working at the Institute of Tropical Medicine in Antwerp, in Belgium. And in our lab, we received a shiny blue thermos that contained 2 vials of blood that came from a Belgian nun.
Why here? Because you have to realize at that time period, we still had that historical link with the previous Belgian Congo. So if there is an unknown disease, send it to the Institute of Tropical Medicine.
If we would have known that this was what we know today as Ebola virus, we would never have opened this thermos. I can guarantee you that, because we were not really equipped to work with such dangerous viruses. We looked at that under the electron microscope, and we saw something completely different than we had ever seen before. The only virus we knew that looked like that was Marburg virus, and that was a shock, because we knew that Marburg virus was highly lethal. And we sent it to Carl Johnson's lab in the Centers for Disease Control in Atlanta, where they confirmed that this is a new virus. We had no idea how frightening it would become.
You hear about a virus that just appears out of the middle of a jungle and can kill 90% of the people, disappears, and then reappears years later. I mean, that's the stuff of nightmares.
Ebola is really damaging. Your organs melt down, you vomit uncontrollably, your blood cells break. It's a repulsive, horrible, painful way to die, and there probably aren't that many more painful ways to die.
If you look at some viruses, they're spherical, they look neat, they look very geometric. If you look at Ebola under an electron microscope, it looks like this really angry, ugly thing, which is befitting the devastating damage that this particular virus can do to the human species.
We have an immune system that's meant to be our first-line defense. But Ebola kind of tricks them and makes them think that it's a friend instead of an enemy. And so the very cells that are meant to protect us are the ones that actually kind of let us down.
The virus is able to rapidly replicate and take over the machinery that your cell uses. And eventually the virus escapes from the cell, and that sets off a cascade where more and more cells are infected in a very rapid and sort of uncontrolled way.
It really has a predilection for the cells that line the blood vessels. Ebola destroys the blood vessel, so things start to leak out, and that's how it causes damage to nearly every single organ in the body. Ebola literally starves them of oxygen.
It's not really possible to identify Ebola when it first emerges, because when the initial patients are infected, it appears like any other tropical disease.
Vague flu-like illness. People get a fever and they ache all over.
These are all things that we associate with malaria, measles, and a couple of other diseases. It's not like you get a big red bump on your head that says Ebola.
After about day 5, when the patient enters the gastrointestinal phase, we begin to see the enormous amounts of body fluid which come out of them. And that fluid is highly contagious.
Ebola looks like really bad food poisoning that doesn't go away.
When they're vomiting, when they have diarrhea or they're bleeding, those bodily fluids can be highly infected. And then a doctor, a nurse, a family member comes into contact with those bodily fluids. When they splash onto their eyeballs, the inside of their mouth, the nostrils, which happens when you're looking after somebody, that's how they become infected.
We'll see patients develop kidney failure, liver failure. And then a certain percentage of the patients go on to have what we call hemorrhagic fever. Not being able to clot and start bleeding out of their intestines and other parts of their body. And all of that compounds into organ collapse and death in the patient.
It's a very cruelly efficient virus that does its damage very rapidly. The average time from the first day that they have symptoms to death is usually 8, 9, 10 days.
As you get sicker and sicker, and if you ultimately die, the amount of virus in your body increases, and you become more and more infectious.
It's almost as if the virus realizes, okay, you know, our host is dead, let's all jump ship, and they're all over the outside of that body.
And so, tragically, when a person dies of Ebola, the body remains very, very infectious to somebody else. And so that is a huge risk, as we saw in West Africa.
Ebola is a very disgraceful and unthankful disease because it affects the people who care about cleaning you, feeding you, making sure that you recover and you get okay. It's the people who later is gonna get infected and probably die. So it's a very, very mean disease.
The Ebola virus takes advantage of our particular love for each other as human beings. And in the case of West Africa, of our very sort of tactile nature, we like to touch. It's very significant in our interaction. From the day you're born, we touch you, to the day you die, we touch you.
So that very act of caregiving, of wiping a fevered brow or cleaning up after somebody can also be the thing that then infects the next family member.
Ebola wasn't new to us. We've known about this infection since the 70s. We should not have neglected it and assumed that every outbreak would look like the outbreaks we'd seen before.
Previous Ebola outbreaks happened mostly in remote villages where they were contained to anywhere from a couple to a few hundred deaths. The perfect storm of the West African outbreak, which winded up with 28,000 cases and more than 11,000 deaths, was the fact that you were dealing with just the right circumstances for a massive outbreak.
Ebola came out of the jungle, effectively. It's where it had been incubated. The first case in West Africa was in Gekadu.
It is believed that the boy was infected by a bat, and he infected his own family as well. And that's how the whole thing snowballed.
This was right on the border, really, of 3 countries, Sierra Leone, Liberia, and Guinea.
3 countries with porous borders, dense population.
This outbreak went on from late 2013 through the first several months of 2014 before it was recognized as Ebola.
No one in West Africa who was infected at first, they and the people around them didn't know what was happening. They thought it was some other disease that they were familiar with. And so, unfortunately, in the way that they were taking care of each other, they were spreading the disease.
Dozens, probably scores of people died before a single case was eventually diagnosed and confirmed in the laboratory as Ebola.
A lab in France has confirmed the Ebola virus as the
Ebola virus is the source of a deadly outbreak in Guinea.
Doctors Without Borders now has more than 30 people on the ground with more on the way.
Anyone who fights fighters will tell you it's those first minutes that make all the difference in the world between being something contained in a minor event or being a disaster. Despite having organizations like Doctors Without Borders coming in, it just wasn't enough. The Ebola fire was not contained early and very quickly became a major alarm event.
If you allow a virus to spread beyond a village to a town, beyond a town to a city, and in the case of Ebola in 2014, across borders into other countries, the epidemic just takes off. And controlling it at that stage is extraordinarily difficult.
We saw the virus hitch a ride on trucks and in cars and on buses to travel quickly from one city to another, where hundreds of thousands of humans live.
It's like fighting a war on many different fronts. There's an Ebola case in Gekidu, and now there's one in Conakry, too. Well, now it's in Bong County in Liberia, and Nimba County, and then in Monrovia, and then Kailahun, Sierra Leone. And so, how many different fronts can you fight on? And we found that, we rapidly outstripped basically our capacity to fight on many different fronts.
If you are sick, one of the things that normally you tend to do is go with your family. I go with my mom, I go with my sister, who's gonna take care of me.
Suddenly, one child is sick with a fever and then gets to the point of death. And then your next child, you might have 4 or 5 children, and 3 or 4 of them get sick and die. Can you imagine what that means to you as a parent? And likely you're going to get it too.
My daddy get this sick here. And Mr. Pamagu.
Lama don't die. Alpha don't die. Anna don't die. Yamari don't die.
Now we 27. Now we 3 survive.
Then once families became major units of transmission, we then saw social events such as funerals, where many people had contact with the infected body, which now transmitted to many other families, almost like satellite events. And so that just fueled the outbreak.
In our culture, when somebody dies, they tend to be washed by their closest friends and family. It is an honor and it is a final act of saying goodbye.
You wash the body, you collect the water, and you use that water to baptize and to wash all the children and all the women and all the people that you think that should be blessed. And then from one funeral, you get 18 people infected of Ebola because of that, because of tradition.
And if they're infected and then they go home to their villages and then they die there and then there's another burial there, the virus is able to move beyond our efforts to contain it.
Trying to counter the cultural practices and the risks that some of these cultural practices posed was very significant. The challenge was in getting people to accept our message about what Ebola was and how it was spread, and to get them to change those behaviors.
The public in Liberia, Guinea, and Sierra Leone do not trust public officials. And why would they? They endured decades of horrific civil wars at the hands of very corrupt leaders. And now those same officials are trying to convince people to not bury their dead, to not touch their dead. Folks are like, whatever, I'm not gonna listen to you. And that really helped the outbreak spread.
Ultimately, anybody who died were supposed to be buried by official responders who were dressed in the plastic bright yellow or white outfits, and they would take those bodies, they would spray chlorine on them to try to decrease the amount of virus, wrap them carefully, and take them off. There were cases where people would die and loved ones would not tell the officials, and they would do these secret burials. I remember talking to a guy who had done that for his mother, and sort of like, oh my God, why? You know you could get Ebola that way, your community, it might have spread. And, but I think we could all understand why this was so scary to people.
They were so unprepared on the ground for an outbreak like this. Sierra Leone, Guinea, and Liberia had suffered decades of civil war. And although that war is over, there are these lingering effects, including a really bad, almost non-existent public health system. And that just left the country wide open.
These are among the poorest countries on the planet. They have doctor-patient ratios that are unbelievable. I mean, it would be like the city of New York had 100 doctors.
There wasn't even clean water. They didn't have access to running water. So how on earth do you go from one patient to another if you can't wash your hands? Healthcare workers weren't able to keep themselves and their colleagues safe, and we saw them die in droves, especially the local doctors and nurses.
The healthcare staff got really, really scared because we were seeing a lot of our colleagues getting infected and in that situation and dying.
Everybody was overmatched. Our best hope at that time was to set up treatment units that would have enough beds just to welcome all of the cases, because people were coming to the doors of the treatment units that were running and there was no space inside.
And you tell people, go home, tomorrow come back, if you're still alive, and I will try to find you one bed.
And these people were dying outside of the gates. They were waiting out of the rain for a space to open up and dying there. And this was horrible. It really was horrible.
By the summer of 2014, the outbreak in West Africa was raging. We were already seeing case numbers in the thousands. And there were doctors on the ground who were signaling the alarm and saying, we can't cope, we need help, this is gonna get so much worse. The world paid them no attention. And that just escalated this outbreak to a level that it should never have reached.
Breaking news in the Ebola epidemic. Christian missionary and Ebola patient Dr. Kent Brantley back in the U.S.
The first time the Ebola virus will be on U.S. soil.
One case of an infection in an American did more to mobilize the Western world than thousands of people dying in West Africa, and that's the reality.
Kent Brantley was an American doctor who had gone to Liberia and, while caring for patients, became infected with Ebola himself.
It woke people up to the reality that this is a devastating and scary disease, and it was a real turning point.
More than anything, and perhaps sadly, it said, hey, this is really important. This is really important. We've got to get our hands on this.
Well, it's worse than we thought.
The deadliest outbreak on record.
The Ebola epidemic has killed over 700.
Almost 900 people.
961 people.
More than 1,400 people.
Around that time, another man sick with Ebola hopped on a plane from Liberia and landed in Lagos, Nigeria, which is one of the biggest cities in Africa. And the WHO at that point said, if it gets hold in someplace like Lagos, we are in really deep trouble.
In August, it was clear that extraordinary measures needed to be taken to control this epidemic.
This morning, I am declaring the current outbreak of Ebola virus disease a public health emergency of international concern.
When that declaration occurs, it mobilizes a lot of forces to be put into addressing the situation.
It really started to galvanize a response. It helped to start bringing in aid on a large scale for the first time.
Fortunately, for a reason completely unrelated to the outbreak in West Africa, We at the NIH and others had been involved in developing a vaccine against Ebola as part of a big biodefense effort established immediately after the 9/11 attacks.
Scientists had developed it, they had tested it in monkeys, and it looked good.
These monkeys were vaccinated, and then they were challenged with Ebola to see if they would actually survive an actual Ebola attack. And the vaccine did indeed protect these animals from Ebola. But of course, we aren't monkeys, we're human beings. So normally what happens is, at that point, you start to then test them in people. But in this case, those fears sort of waned post 9/11. We just put it on hold. And we had no idea whether the vaccine would work in human beings.
It took this outbreak to get WHO to really put a focus on getting vaccines out of their early studies and try them out in people.
It was this dramatic race to try and beat the virus, to speed up development of any promising vaccines or treatments that were out there.
Usually when you want to start a phase 1 trial, it takes months, potentially a year, before you can start. Here, the first trial started in weeks.
One of the most important things with vaccines, since you're giving it to people who are well, is safety. And that's why you do a phase 1 trial.
And you're asking a couple of basic questions. Is the vaccine making you sick? Is the vaccine eliciting some sort of immune reaction in you?
A phase 1 trial is a relatively small number of people because if there is a devastating adverse effect, you don't want to have vaccinated thousands of people and say, oh my God, 20% of them are getting this problem. Whereas if you start with a smaller number of people, if there is an obvious, egregious adverse event, you'll know right away and you stop.
There were multiple clinical trials in parallel, so as to accumulate in the shortest possible time as much information as possible to be able to determine whether it was worth starting to test this vaccine in the affected population in West Africa. What we were proposing is to vaccinate tens, hundreds, thousands of people with that. And if we don't believe that this is the right thing to do, we shouldn't do it.
It was unlike anything I've ever seen before in terms of how rapidly all this unfolded. People started to realize that this was an extraordinary situation and an extraordinary opportunity if they could move fast enough.
At the end of September of 2014, the Ebola epidemic was still out of control. But to take a vaccine from a scientific laboratory into human populations in the midst of an epidemic, that had never been done before. So it was a race against time. One of the most promising vaccines we were testing was the VSV vaccine.
VSV is vesicular stomatitis virus, and it's called a vaccine platform.
This is a harmless virus, harmless to humans, that affects cattle, and they modified it genetically to tack on a little piece of the Ebola virus.
It's a bullet-shaped virus, and it has a coat, a spike coat around it. That spike is how VSV gets into a host cell. Ebola virus also has a coat on its surface. So what we do is we engineer the VSV so that we take off the gene that encodes for that protein, and instead we put in one that encodes the Ebola surface protein. But it doesn't cause Ebola because it doesn't have all of the other Ebola genes. So what happens is it tricks your body. Your body sees Ebola, so you generate an immune response against it.
The immune system's ready for Ebola. It knows it's an enemy. It knows what kind of cells to make, what kind of response to launch against it.
We knew the vaccine had 100% protection in non-human primates, so it was very frustrating not being able to employ that vaccine at that time.
The eyes of the nation are on the city of Dallas.
The first patient to be diagnosed with Ebola in the United States. The second American infected with Ebola, a nurse in Dallas.
North Texas school system shutting down.
Test results on the New York City doctor have come back positive.
This guy wandered around New York City for at least 6 days. Where do you begin?
Although we understand the fear of the American people, we respect that fear, They need to understand that you will not get it if you don't have direct contact. The wave of fear and panic in this country was completely out of proportion to the reality of what the particular danger is. To get infected, you have to have essentially direct contact with a very sick person in which there are bodily fluids to which you come in contact, which was a very unusual situation in the United States. The point is, the risk for someone who is taking care of a patient with Ebola is a finite risk. The risk to the general public, in which they're not anywhere near a sick person, there really is no risk, and that's the point we had to get across.
There was never going to be a big epidemic of Ebola in this country because we have clean hospitals and sanitation, and we have things that they don't have in Africa. And that prevents those things from spreading.
We have the healthcare staff in place, we have the public health infrastructure to diagnose this early enough that when that 1 or 2 or 3 people have Ebola, you contain them early on enough that they don't spread it to others.
Nothing did happen. There was no Ebola outbreak in the United States. That's not to diminish the danger of Ebola, but we need to look at these things realistically.
What we were able to do in the US and Europe was to offer patients very, very good clinical care. And I think as a result of this, only 5 out of 27, or 18.5%, died. And we contrast that with West Africa. The case fatality proportion was up to 70% or higher in some situations.
We don't have any proven therapeutics against Ebola. But what we have shown is that if you can support an individual who's infected with good nutrition, good hydration, you'll help support the immune system. And the immune system then, for many of those patients, can go on and do the heavy work of clearing the virus and ridding the body of the infection.
We didn't do anything to cure any of our patients' Ebola. They did that themselves. What we did was help buy them time, the time they needed for their own bodies to take care of the Ebola virus disease.
We now understand how Ebola viruses work pretty well. You can stop these things, and people have to remember that. These viruses are not magic. They're dangerous, but they're not magic.
During the latter half of 2014, and certainly coming into 2015, before vaccine had been tested and we could demonstrate that it actually was safe to use, many, many things changed in West Africa. There was enormous investment from the United States government, from France, from China, from the UK. It's an enormous challenge. Everything that you might take for granted is either overwhelmed or non-existent.
Medical personnel were in short supply. Places to treat people were in short supply. Supplies were in short supply.
The international support was indispensable, both in terms of human capital and also in terms of material.
They built up the infrastructure to have Ebola clinics that had things like water and had rubber gloves and had a space where you could put Ebola patients confirmed with the disease here and the suspect patients over there, so you weren't jeopardizing everybody's health.
The ability to care for large numbers of people was crucial, because until that moment, it had been putting people into a hospital and never seeing them again. And so people saw, in fact, that people were recovering from Ebola. They were going into hospitals and they were coming out alive. And I think those stories of people that survived were hugely important in changing the way the communities thought about this infection. And that started to turn the epidemic.
What wasn't emphasized early on in the outbreak in West Africa is that communities must be rapidly engaged and must understand how they can participate in stopping its spread. Once communities understand that, they're the best partner you can have.
We organized ourselves very much as if we were fighting a war for the very existence of our country, and we felt we were. Because right up till then, Ebola had been chasing us. We were reactionary. We needed to chase Ebola. We needed to stop being Ebola fighters. We needed to start being Ebola hunters. So find the virus, surround and control it, isolate it, and prevent it spreading from somewhere else.
People stepped up and took on responsibility for informing their communities of the dangers and trying to persuade them actually to change their ways. And they were putting themselves in danger too. There were people who are unsung, really, like those who were collecting the corpses, those who were mopping up the mess in the houses and decontaminating places. These were very hard jobs to do.
World Health Organization officials say the outbreak has reached a turning point. Dramatically fewer people are getting infected, down from 300 a week to just 8 a day.
While the good news is that the number of infections went way down, the sobering aspect of that is that it made it very difficult to prove that a vaccine worked when you have so few cases.
With Ebola, the only time you can demonstrate whether a vaccine works or not is when an outbreak is happening. So it was a critical time because we wanted to learn as much as we could from the vaccine so that when there's another Ebola outbreak, 11,000 people won't lose their lives.
Guinea was the last real part of the outbreak still standing. It was the only place where vaccines could be tested effectively against an ongoing outbreak. So it became just the vital study. There was a lively discussion about how best to test vaccines in these circumstances. The most ingenious idea was this concept of ring vaccination.
A ring vaccination strategy is, instead of broad blanket vaccination for the whole country, you go to where there is a case.
You identify an individual with Ebola and then go to that community and offer the vaccine to everybody who may have come in contact with that individual with Ebola. And so it creates a firewall around that community. So if the individual who had Ebola passed it on, those individuals would be protected by the vaccine.
What we decided to do is that, because you need to have a controls, there would be rings that would be vaccinated immediately, and rings that would be vaccinated not immediately, but after 3 weeks.
The comparison was, what were the relative number of infections in the ring that got it delayed versus the ring that got it right away?
What they ultimately found was they had vaccinated about 6,000 people. And the people who got the vaccine immediately, there were no cases of Ebola. The people for whom the vaccine came after a 3-week delay and they had some limited exposure, 23 of those people did end up developing Ebola. So the vaccine appeared to be 100% effective in people who got it immediately in this group. The vaccines probably played a very, very small role in the end in controlling Ebola, but it was the first proof that this Ebola vaccine actually would work.
It was a very important observation that in an outbreak of Zaire Ebola, this is the vaccine that you know you can bring in and quickly bring about control because of the very rapid rate at which people developed immunity.
We changed the disease from having no drug, a very high mortality, to give hope that actually we now had a vaccine which was safe and effective and can be used in the next epidemic. Those moments don't come along very often.
As bad as the West Africa Ebola outbreak was, we were kind of lucky that there was actually already an Ebola vaccine that had been developed and could be tested in people. So even though it didn't stop the West Africa outbreak, in the next outbreak, it could help. But we have to be prepared because it's going to happen, and we don't want this to get out of control again. It could get even worse the next time.
Now we have a vaccine for Ebola that we know works. But imagine we had that 3 years ago. This whole situation would have looked so different. We shouldn't be finding opportunity in outbreaks. We should have done the work to be prepared. There were promising vaccines in development that were sitting on shelves. We can't afford to do this. The virus is always going to be faster than us.
We learned a lot more than just about vaccines in dealing with Ebola in West Africa. We learned really how important it was to bring resources to bear quickly and not to let things smolder along, which would happen for far too long with this outbreak. New viruses are emerging all the time. These are not necessarily even novel viruses. They've just been hiding out in really remote areas. But now that there's so much movement of human beings around the world, any outbreak anywhere can easily catch fire and can start spreading really rapidly. So this is an unending battle, and we need to remain vigilant all the time.
People ask me, because I work a lot on viruses and emerging infectious diseases, which one are you most afraid of? And I'll be honest, I'm most afraid of the one I don't know about yet. And that's exactly why we're looking to stop chasing the last thing and get in front of the next thing. We're here today looking at this interface between people and animals, where people live really closely with animals, and this happens to be a village right on the edge of a forest that's heavily used by people. The team here is getting the sample straight from the monkey's mouth. And then just down the path, we'll take it to a station where we have those samples spun down and get the saliva pulled out of the swab, and with that, the viruses. And we get that into deep freeze right here in the field so that we preserve the ability to detect viruses like Ebola that they couldn't detect in this region because they weren't ready for it, and also to detect new ones.
So many of these emerging infections start in animal reservoirs. They can be in monkeys, they can be in apes, in bats, in pigs, in ducks, in chickens. And the way that human beings are now encroaching and changing the environment around us, that connection between animals and humans is changing.
We're looking to understand better what viruses are here before they spill over, and help to understand the behaviors and the ecology and the demographics of all of the scenarios to help stop that risk. The idea is to work with communities to be ready so that the West African Ebola outbreak never happens again because the systems are ready, but also to know ahead of time what viruses they have in their communities so that they can take control of their own behavior.
Ebola's not gone anywhere. It's still here. We will see more outbreaks, and now we'll probably see them in many more parts of the world.
I think Ebola was a clear, cogent, dramatic example that emerging and re-emerging outbreaks have always occurred, and they will continue to occur. So what nature is trying to tell us, the lesson learned from Ebola, we have to be prepared for things before they occur, as opposed to always reacting to them.